Let's keep going. Now, we're going to look at parallelograms. Remember that a parallelogram has two sets of parallel sides. A square, rectangle, and rhombus are parallelograms. Let me give you those examples. Here is a rectangle. It has two sets of parallel sides. I'll color them for you. This side here and this side here are parallel. And this side here, oops, my color didn't change there. This side here and this side here are parallel. That's a parallelogram. Okay, good. There's three kinds of parallelograms you might remember. I'll try to sketch them. A square, a rectangle, and a rhombus. Now my sketches are not perfect, but you get the idea. Okay, next. Prove that a rhombus is a parallelogram. Here's a rhombus. It has two parallel sides, there, and these sides here. But let's prove that they're parallel and that this is a parallelogram. Okay, follow the instructions. It says, here is triangle ABC. Draw midpoint M of side AC. So we want to draw the midpoint on side AC, the midpoint of this line. To do that, click on the midpoint tool. Click the tool, and down here are directions. It says midpoint or center. Select 2 points, a segment, circle, or conic. Well, we just want 2 points. So I'm going to click A and C, and then ding, it puts a point where the midpoint should be. Okay, we did it. The instructions say, draw midpoint M of side AC. Here's the side AC, and we drew midpoint M. Okay, now you do it. Then go down to the next applet. It says, rotate triangle ABC 180 degrees using center M to form triangle CDA. Draw and label this triangle. Let's put the midpoint back on here now. So go to the midpoint tool and click point A, C. Okay. Using center M, we're going to rotate triangle ABC 180 degrees. Do you remember what you just learned about 180 degree rotations? Remember that when you rotate a line segment 180 degrees, you get a parallel line. So let me sketch in what I think this is going to look like. Here is line BC. And if I rotate around the center here, M, I'm expecting a parallel line. Probably, let's see, C is going to go over here, and B is going to go over here. Something like that. So this is going to be C prime, and this will be B prime. Let me change colors, and I'll estimate other lines here. Okay, what about when we rotate segment AB 180 degrees? Can you imagine? Well, I think A is going to go over here, and B is going to go over here, I think. Something like that. Okay, and then what about when we rotate segment AC? When we rotate a segment AC 180 degrees, what do you expect to happen? Well, it's just going to stay on its own line because it's on the center of rotation. The center of rotation is here on AC. So I expect point A prime to be here, and C prime to be over here. Something like that? Okay, let me try it now. Click the rotate around point tool, and then click the shape. Click the center point of segment AC as your center of rotation, and then put in 180 degrees. Ding! Wow, cool! Okay, I'm excited, but maybe you're not. I don't know. Did you expect that to happen? I did. Look, there's my B prime, C prime, A prime. I expected that because I know when you rotate a line segment around, when you rotate a line segment 180 degrees, you get parallel lines. I want to draw the parallel lines in a little more so you can visualize this better. Oops, wrong tool. There we go. Here, this is parallel to this side. When we rotated this line segment, it went 180 degrees over to here. I'll change colors. And this segment here, I think I need that a little bigger. This segment here is parallel to this segment here because we rotated. It went 180 degrees over here. Okay, let's answer the questions. And I'll leave my marks there. So nice. Okay, the question asks, what kind of quadrilateral is ABCD? So now we have ABCD. I don't know where it put the D on here though. ABCD. Anyway, what kind of quadrilateral is ABCD? Explain how you know. Okay, I'm just going to label this so it is clear for everyone. This was A, B, C, and we're going to call that D now. What kind of quadrilateral is it? It has two pairs of parallel sides, so it is a parallelogram. How do you know that? How do you know that it's a parallelogram? I know that, sorry, I forgot a space. I know that a 180 degree rotation of a line segment results in a parallel line segment. So, AB is parallel to CD, and BC is parallel to AD. Let me say it again. It is a parallelogram. I know that a 180 degree rotation of a line segment results in a parallel line segment. So AB is parallel to CD and BC is parallel to AD. Should I review it one more time? AB, oh no, why is that black? I'm sorry, this one. AB is parallel to CD because this line segment was rotated 180 degrees, and that gives me another parallel line. And let me get a good color here. BC is parallel to AD. I know that because it was rotated 180 degrees, which results in parallel lines. Okay, let me erase all my marks. Yours is going to look like this parallelogram here. Remember, rotate triangle ABC around the midpoint right here. Rotate 180 degrees. Next question. Right here. The next question asks you, in the activity, we made a parallelogram by taking triangle and its image under a 180-degree rotation about the midpoint of a side. This picture helps you justify a well-known formula for the area of a triangle. What is the formula and how does the figure help justify it? Okay, so think about that first. It says, this picture helps you justify a well-known formula for the area of a triangle. What is the formula and how does the figure help justify it? Okay, think, what is the formula for area of a triangle? I'll let you think about it before I spoil it for you. Okay, did you think about it? Let me help you. The area of a triangle equals 1/2 base times height. But how did our GeoGebra work help you justify that? Well, we have a triangle here. Oh, I have the wrong tool. Sorry. This tool. We have a triangle here, and we said that the area of a triangle equals 1/2 base times height. But how does this figure help you figure that out? Well, look carefully. There's two triangles, right? So what would be the area of this parallelogram? The whole parallelogram's area is going to be, the area is going to equal base times height. Yeah, the base here times the height here. So if half of that is one triangle, then what is the area of the triangle? Then it's going to be the area of the parallelogram divided by 2. So the area of the triangle, as you know, is 1/2 base times height. That means the base of the triangle times the height of the triangle. It could be this base and this height, even though that's upside down. We think of base on the bottom, but whatever. Okay, I want you to answer that in your own words. I can help you. The area of a triangle is 1/2 of the area of a parallelogram made by rotating the triangle 180 degrees around the midpoint of one of its sides. Let me say that again. The area of a triangle is 1/2 of the area of a parallelogram made by rotating the triangle 180 degrees around the midpoint of one of its sides. Does that make sense to you? I can review it one more time if you like. Here's the triangle, and here's the midpoint of one of its sides. Now, if we rotate 180 degrees, then we get something like this. So I said the area of a triangle is 1/2 of the area of a parallelogram made by rotating the triangle 180 degrees around the midpoint of one of its sides here. So what is the area of this triangle? It is 1/2 the base times the height. There we go. I'll type that formula in. The area of a triangle is 1/2 base times height. Oh, more spelling. Okay, good job, guys. Now you need to put in your answers. Think about it. Make sure you understand. Watch the video again if it's confusing. Let me help you.